Today we're on pages 104 and 105 of our textbook. It'll be helpful if you have a calculator. R values for multiple or fractional time periods. Given the exponential growth formula, capital A equals lowercase a times 1 plus r to the t, when t equals 1, meaning time 1 year, solve this for r. This will give us an annual growth rate. Substitute 1 in for t. So 1 plus r to the first is simply 1 plus r. And if we want to solve this for r, right now we have a times 1 plus r. We'll undo the multiplication by dividing by a. That results in, we have capital A divided by lowercase a equals 1 plus r. And now one more step and we'll have r by itself. Subtract 1. So capital A divided by lowercase a, subtract 1 equals r. Finding the annual rate of growth. Find r when t equals 1. Exercise number 1, we have a population of wombats is growing at a constant percent rate. If the population on January 1st is 1,027 and a year later 1,079, what is the annual percent growth rate? Well, what's our capital A and what's our lowercase a? Remember, lowercase a is our starting. That's our 1,027. And a year later, the population is 1,079. Using our formula above, that r equals capital A over lowercase a subtract 1, we get 1079 divided by 1027. Subtract 1, go to the calculator. And we have 0.5, I'll write out the whole decimal, 0.05063291114. We want its annual percent growth rate to the nearest tenth of percent. Okay. To change this to a percent, we multiply by 100. Take this decimal that's on the calculator, this is going to change it to a percent. Times 100 is 5.063291139. Nearest tenth of percent would be 5.1%. If making time larger, we raise our yearly base to a whole exponent. If making time smaller, we raise our yearly base to a fractional exponent. Finding the percent growth over multiple years. This is when t is greater than 1. Let's determine the percent growth in wombat population over a decade. This is where our time is 10. Assume the rounded annual percent increase found in exercise number 1 continues for the next decade. We will take our 1 plus 0.051 and raise it to the power of 10. What does this equal? Definitely use the calculator. .644. So this is our new base for over 10 years. This base was yearly. This is a yearly base. Now, raising this to the power of 10, 1.644474564 This is our 10-year base. Well, that's a base, so what is R? Well, this represents 1 plus R over 10 years, right? This decimal represents 1 plus R over a 10-year period. So if we want to find R, we simply subtract 1. So we're on the calculator, subtract 1. So R is equal to 0.64447, so on, and we want this as a percent, so we times it by 100. 64.4 to nearest, doesn't say. We'll go to nearest 100%. So the rate for 10 years would be 64.45%, when the rate for 1 year is 5.1%. Finding the growth rate for a fraction of the year. This is when t is greater than 0 but less than 1. So we're using that same example with our wombats having a yearly growth rate of 5.1%. Use the wombats from exercise number 1, assuming their annual growth rate is constant. What is the monthly growth rate to the nearest 10th percent? Okay, so our 1 plus 0.051, that's still yearly. That's our yearly base, because R was 5.1%. If we want to go to a monthly, monthly is much shorter, it's much smaller. What portion of a month is a year? Or rather, what portion of a year is a month? It's 1/12. So we're going to raise our yearly base to the 1/12. 1 month is equal to 1/12 of a year. Calculator. 1 plus 0.051 raised to the 1/12. So this is our new monthly base. This is our monthly base. What is the rate? What's our monthly rate? Well, so 1 plus R equals this for our monthly base. So we simply subtract 1 on the calculator and then times it by 100. So R equals 0.42%. Oh, to the nearest 10th percent. Okay, sorry. So 0.4%. If a population grows at a constant rate of 22% every 5 years, what is the percent growth rate over a 2-year time span? Round the nearest 10th of percent. First, write an expression that we could use to calculate the yearly base. Okay, so that 22% is for 5 years. So 1 plus 0.22. This is a 5-year base. What's our yearly base? We would take that, and 1 year is 1/5 of 5 years. So we take our 1.22 and raise it to the 1/5, and this will get us our yearly base. It says to write an expression. Okay, so I'm not using the calculator. Here's our expression for a yearly base. Now use this expression to calculate the percent growth over 2 years. We would take our yearly base, and if we want 2 years, we would raise it to the power of 2. We'd square it, which is the same as 1.22 to the 2/5. And then calculator, 1.22 raised to the 2 divided by 5. Subtract 1. And multiply by 100. 8.3%. Exercise 5, the populations of squirrels in Ulster County is growing at an annual rate of, so this is an annual rate of 1.8%, means our lowercase r is 0.018. Find the percent rate of growth for every 2 years, 5 years, a decade, and then monthly. Okay, so 2 years, that's a larger time span, so we raise to the power of 2. 1 plus 0.018 raised to the power of 2 using the calculator. Then we subtract 1. My pens are not agreeing with me today. I'm just going to go 4 decimals. Subtract 1. And then multiply by 100. So 3 to nearest tenth of a percent, 3.6%. For every 5 years, we'll take that same yearly base and now raise it to the power of 5. And again, do this all on the calculator. I'm just going to go, not that way, arrow up, grab that, change the 2 to a 5, subtract 1, times by 100. 9.3%. Every decade, we take our annual, raise it to the power of 10, minus 1, times by 100. .5%. Now monthly is a smaller portion of a year, so this is where we raise to a fractional exponent. We're raising to the 1/12. Same thing, once you get that decimal, subtract 1, enter, times by 100. 0.1%. Exercise 6, world oil reserves. The amount of oil unused in the ground are depleting, so here we're decreasing. Right? Everything we've done so far has been growth, and now here this question involves decreasing. This is decay at a constant 2% per year, so this is our R value. 0.02 is a decimal. Determine the percent decline over the next 20 years based on this 2% yearly decline. Write and evaluate an expression for what we would multiply the initial amount of oil by after 20 years. This is 1 minus R. So 1 minus 0.02 to 20 years. So approximately 67% remains. use your answer to A to determine the percent decline after 20 years. Let's simply take, so 1 minus, or 100, since we're in percentages, 100% minus 67 is going to be 33%. Number 7, a radioactive substance. Half-life is the amount of time needed for the half, or 50% of the substance to decay. A certain radioactive substance has a half-life of 15 years. First, give an expression that will calculate the yearly percent decay. Well, this is 50% in 15 years. So 1 year would be 1/15 of that. 0.50 raised to the 1/15. .9548. This represents a yearly, this is our yearly base now, which would represent 1 minus R. So just like we were finding our percent growth for percent decay, we would subtract 1 from this value, but ignore the sign. All right, just subtract the 1, ignore the sign, and times it by 100. So ignore the sign. So this would be 4.5%. Here's the yearly decay rate. What percent of the substance would be radioactive after 60 years? Well, we can take the annual and raise it to the power of 60, or we could take the half-life, the 15 years, and raise it to the power of 4, because that would be 4 15 years. So 0.5, apologize for my markers, keep going to eraser. 0.50 and raise it to the 4th, which should be approximately the same as 4.5 raised to the 60th. Minus, come on, 1 minus 0.045 raised to the 60. Let's see. Close enough, right? We have some rounding with our 4.5. Times by 100. So it's asking us for a percent. So this would be approximately 6.3%. These markers. Approximately. What percent of substance would be radioactive after 5 years? Okay, so I'll take the yearly. And raise it to 5. Times by 100. lastly, exercise number 8. Rewrite the following in the form capital A equals lowercase a times 1 plus or minus r to the t. State the growth or decay rate, r. Okay, so first, we want to write it as capital A equals lowercase a times a base to the power of t. So in number 8a here, right now we have this base 2 raised to the t divided by 3. We want to split this up. This would be 2 to the 1/3 raised to the power of t. Simply rewriting 2 to the t over 3 as 2 to the 1/3 raised to the t. Because when you have a power to a power, you multiply the exponents. Well, what is 2 to the 1/3? It's this decimal, 1.2599. So a equals lowercase a times 1.2599 raised to the power of t. And the growth or decay rate, well, this is definitely a base that's greater than 1. So this is growth. And the growth rate would be subtract 1 times it by 100, approximately 26%. You've got that, subtract 1 times by 100, approximately 26%. Next, this is all practice with rewriting our base and exponent. Gosh, it's not working for me. All right, didn't want that. I wanted just my base and exponent. So this would be 4 to the 5/6 raised to the t. Four to the 5/6 in the calculator. This also is growth, because our base is greater than 1. And that's large growth. Subtract 1 times by 6 times by 100. 217. I think there's a typo here. I think that's just supposed to be to the t over 6. 217% growth rate. And try the last two on your own if you want. And then check. This is decay, because our base here is less than 1. Disregard the sign, so this is approximately 6%. Base is this 0.8572, subtract 1 times 500, approximately 14%. And this was decay also. Alright, sorry it was so long and I had so many problems with my pen switching to eraser. Thanks so much for your attention.